Evaluate the limit as x tends to 0 of 1 over sine x minus 1 over ln 1 plus x. Now, these two expressions I have power series for centered at 0. So let's try and apply power series to this situation. Okay. Now the first thing we're going to do is we're going to get a common denominator here. Okay. So that way we can simplify it into a nice single fraction. And then we will bring the power series for these expressions in. Okay, so we know power series for ln 1 plus x looks like x minus x squared over 2 plus x cubed over 3 minus x to the 4. I mean, we don't really need that many more terms. Usually the first three get the job done, although we can always come back and add in more if we need them. And sine x looks like x minus x cubed over 6. That's probably good enough. But if we need to, we'll add in the next term, x to the 5 over 5 factorial, which would be 120. Okay, now I'm seeing that there's the difference of these. I'm also seeing that there's a product. So we're going to have to work those out. But fortunately, adding and multiplying power series is something we've practiced. So, actually we can subtract them here. So the x's will cancel out. There'll be a minus x cubed over 2. And then, what do we have? The x3s, it'll be a plus x3 over 2. And then some higher stuff as well. Yeah, 1/3 plus a 1/6, because it's minus minus. Yeah, okay, we're good. And multiplying them, well, we'll just set up a nice little Cayley table. Doesn't matter which one goes where. Yeah, so we multiply through, we get x squared, a minus x cubed over 2. The powers aren't quite going to line up here, but that's okay. We'll get a minus x to the 4 over 6, and plus x to the 5 over 12. If you really want it, we can do the next term in the ln power series and get the other bit for the x to the 4. Okay. But, I mean, I'm seeing an x squared, x cubed. Everything here is going to be higher. So those are the smallest ones. And then I suppose we could combine and get an x to the 4 over 6 if we really want it. Okay, but we only need the first few terms. So x squared minus x cubed over 2. And then for the people who like that sort of thing, x to the 4 over 6 plus some more stuff. Alright, having worked out our power series, now we bring them in order to calculate our limit. So it's ln 1 plus x minus sine x. Okay, so plus x to the 3 over 2 plus some higher order stuff. All over the one we just worked out. And if we factor out x to the power of 2 on top and bottom, those x squareds will cancel out. Right, we'll have a bunch of stuff that has x's in them, and when we plug in 0, that'll all go away, leaving only minus 1 over 2 over 1. So the answer here is minus 1/2. That is going to be the limit for this expression as x goes to 0.